happens. So in the push 3, some similar graphs are drawn in the two lateral things, and what we mean by hinges in the columns, you can see very well that these are what you have as your hinges in the columns. So what happens is that in your pushover analysis, what we do is that I have given one example, pushover analysis example now we are going to take. It is a ground truss 15-story structure which we had taken up for study purposes without any, let us say, without any shear walls. There were two models which were tested, one with shear walls, another without shear walls. And in one model, what we did was that we used only rectangular columns, and in the other model we used equivalent square columns. That is, the square columns which are using the same material as the rectangular, but we wanted to compare the performance of your rectangular column versus square column in this case. And the building data was taken something like this with panel size of 4.5 by 4.5 meter, story height, and so on. These are some examples which are given, some loading, how we use the loading, and earthquake loads were given as per the zone number 3 and so on and so forth, the characteristic strength, and the geometry which was considered. This is the rectangular column geometry, and as against that we had the building plan with a square column geometry, and this was given to your plastic hinges which were defined were the default plastic hinges were used as the action hinges, the flexural hinges corresponding to your bending moments, and then you have shear hinges at the two ends of the beam. So beam elements were given flexural hinges at the two ends of the midspan, at the two ends and midspan. Usually midspan hinges will not be stressed, but still, just because for our purposes, if you have very heavy loads, in case of very heavy buildings, you may have sometimes your midspan hinges also developing, and the shear hinges at the two ends. And in the column elements, we had only defined your PMM hinges, that is your axial and the biaxial bending hinges type of hinge. So P, M2, M3. M stands for M2 and M3 hinges at the two ends. And then the seismic performance of the RC frame without shear wall. This is a 3D model which was taken up. And then the performance point, if we see, if we compare for the rectangular column, this is the performance point, and for the square column, this is where the performance point is occurring. And you will have, we compared these results, and if you compare the results, what happened was that when both the buildings were following all the codal provisions, still if you can see that there were hinges of the magnitude of LS to CP. What is LS is life safety to collapse prevention. In that range, you had 224 hinges in the rectangular column model, and in the square column model we had 164 hinges which were lying in the range of life safety to collapse prevention. That means it was quite on the non-linear side. So what happened was that if we see this result, then the deformed shape under your push X, if we see the rectangular column and square column, it seems something like this. And further, the frame-wise hinge formations, if you see at the performance point, this is the figure which shows for various frames in 2D. These are 2D frames which we have selected. So these are for the square columns, and for the push-wise similar things were seen. And in the other direction, see, one direction, X direction is your stronger direction, Y direction is a weaker direction, you can see. Okay, so what will happen is that in the Y direction we had some results looking something like this. I will not bother you now. What we did was that we wanted to keep our building in immediate occupancy stage. So what we needed to do was that all the hinges which were developed up to the performance point beyond the immediate occupancy stage were to be eliminated. Okay, so for eliminating those hinges, what you need to do is that you have to strengthen your building, or maybe you have to introduce some sort of a ductility into your building, or let us say that we see that the hinges are not going beyond the elastic limit or whatever we wanted. So what we did is that we changed the cross-sectional properties of the columns and the beams such that none of these, now you can see the same results, you can see that these are zero hinges which are developing, and only your hinges are developing up to your immediate occupancy stage. So what we did is that we studied the models under your normal cases. So see, understand that the first model which we had analyzed was already following provisions, but still the hinges which were developed were beyond your elastic limit. Okay, under the same earthquake load. So the earthquake loads we are not changing. What we are changing is the properties of the building. And we wanted to find out that if your client says that I want my building to be in the immediate occupancy stage only, then do you have a tool to do that? And yes, we have that, and we have done that, let us say the cost estimation as well. So in the push direction, and these are some drift, let us say, Storey Drift figures which you can see, something like this for rectangular and square column. The drifts are looking something like this. And further, if we talk about the quantity of steel material which was the structural material which was required, that is basically the quantity of concrete and steel, we can compare that for normal building. That means the building which was not modified, the building as it was passing the codal standards, that is what we call as the normal building. It was consuming this amount of material which you can see on the left hand side, and the same building when it was up to the immediate occupancy level. Now what happens is that your material is going to naturally increase. This is for your rectangular column, this is for your square column. So what will happen is that your concrete consumption is increasing from this to this in case of your square column model, and in case of your rectangular column model it is increasing from year to year. And at the same time your steel quantity is moving from this to this, and you can see for the square column model your steel is slightly less which is consumed, and that is what we saw, and this is what is the application of your pushover analysis to keep your building in the immediate occupancy stage. We can do something like this. The structural cost finally came out to be this. We have saw a number of such examples, and with that I think I'll try to finish this presentation. Thank you very much. I would acknowledge including the sponsors and all of you. I would like to thank you, and I would conclude with a social message which we have been following since some time. Thank you very much. I hope I have not kept you waiting to go home. And I hope that we have all learned, at least for me, I have learned a lot of new things today. And if at all you have any questions, I will take that. Okay? Thank you very much.
Yeah.